Hi all, I welcome you to the Building Culture podcast where I invite incredibly smart people who build things. Whether they be engineers, entrepreneurs, programmers, hobbyists or researchers, it does not matter. As long as you're someone who's passionate about building things, I'll find you and podcast you. Hi all, I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now. In today's episode, we have with us the co-founder of Sewts, which is a TU Munich-based startup that aims to solve the most complicated challenges in robotics that deal with deformable object manipulation. Since he is the co-founder of this company, he has been involved in multiple different areas ranging from mechanical engineering and design to actually also hiring and recruiting people and a lot of other steps involved in the process throughout the journey. It was truly a pleasure talking to him about all the different areas of his involvement at Sewts, about the vision and mission of Sewts, about his own personal motivations and his mindset behind what inspired him and his co-founders to start a company directly after finishing their masters at Technical University of Munich in mechanical engineering. So without any further ado, let's welcome Tim Doerks. Okay, Tim, so let's start with what the starting point for Sewts was. What's your story of founding Sewts? How did you begin with it? Can you elaborate on that a bit?
hmm Yeah, sure. First of all, thanks for having me on your podcast. So yeah, I'm curious how the next 1 to 2 hours are gonna play out. So yeah, when you let's say look at the story of Suits, you could say it starts very early because yeah, the three of us who founded the company have known each other since 2012, like first semester mechanical engineering class here in Munich, and yeah, we've always been friends ever since. So that's basically where I would say the initial starting point was. Like that's probably without those two friends and now my co-founders, this would not have been possible. Um, let's say the more concrete starting point is probably sometime in October 2017. So in Munich, I used to live in Studentenstadt, which is like arrangement of lots of student dorms, like 3,000 dorm rooms, and yeah, there Alex and I used to have the occasional beer, let's say, in the evenings, and I don't know, talk about many different things, and it somehow came to the point that we started talking about manufacturing of clothing, and uh, Alex was like, "Yeah, did you know that t-shirts are all made by hand, basically?" And I was like, "Oh no, come on! Like everyone has so many of those. That's insane. That's probably automated." And yeah, from that conversation on, we kind of yeah went on about this topic for longer and longer periods of time, and we're like, "Yeah, well, this is really not the case. Like everyone has these in their closet, and they're all made by hand." And so since we both have a background in, let's say, mechanical engineering, specifically in the area of technical textiles and carbon composites, we we kind of spun the idea further and came up with the initial founding idea of Suits. I think somewhere in February 2018 or so, when we were skiing, and we thought like, wow, the vision behind the company has to be to, let's say, solve the most difficult problem in sort of textile manufacturing, textile handling. And so we came up with the name Suits, which means to sew a suit basically. And we thought, okay, so this must certainly be the goal, right? If this problem is solved, then um, the whole thing is done. Then we can pack up and be ready, kind of.
Yeah. So the idea was that you were trying to solve the most challenging problem that would be in the area of robotics. So there are actually two aspects of this, right? One is about selecting textiles or fabric as an area in which you wanted to do it, and the other part is about doing a startup. So let's first talk about the fabric area, how you actually came about deciding it. So you mentioned that you talked with your co-founders Alex and Till also probably at that point about the possibility of fabrics, and that you were surprised by the fact that they are not fully automated. So how did that actually eventually lead to something concrete that you would actually want to do a startup in this particular area?
Yeah. Yeah, so in the end of our bachelor's degree, we were able to make some choices regarding our different subjects, let's say. And so one was, let's say, the basic course at the chair of carbon composites, and it's the first time ever we got to know about, let's say, easily deformable materials from a academic point of view, kind of. And then obviously there's planes and there's wind turbines and all sorts of different areas, but it never kind of touched on the apparel or, let's say, clothing side of it. And so the 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 general complexity of the topic was just very interesting, to especially Alex and me. And so we both wrote our bachelor thesis at that chair, and then our semester thesis, which we also have to write, kind of similar to a bachelor's thesis in the master's, then also at that chair. And yeah, then it's been quite the focus area, let's say. So then you get to know about all those difficult problems in the realm of textile. So it was a, let's say, pre-focus towards that uh, yeah technology, or let's say that sorts of problems. And so Alex was always drawn a bit more towards the, let's say, the fluid and the simulation part of it, and for me it was more about the prototyping and let's say tinkering. And yeah, that's somewhat what led us to pursue, let's say, different areas here. Yeah.
Yeah, so it's actually started with you selecting a thesis topic. So you and Alex actually selecting your thesis topic in the area of textiles, and then slowly and slowly you took up in your masters as well, and other topics similar to this. So you kind of had really good understanding of textiles at that point, and then eventually when did the third co-founder Till also joined you? At what point did he join you?
Yeah. So let's say that was actually still quite early. So uh, we must have been somewhere in March 2018, something like that. So we had, let's say, the initial idea, so the vision ready, and we were thinking about, okay, how can you could you build a product in that area, like which was really, really abstract. And so we kind of asked Till if he was interested as well. At that time, he was uh, eventually gonna look at let's say career in the automotive field, and we talked to him about like our idea and vision, and it became clear pretty quickly that he thought it was a pretty awesome thing to pursue eventually, and so yeah, we had known him for like so many years already then, and like for Till, Till has this amazing let's say skill that like whichever problem you pose him, he will come up with a solution. Like I think I have never seen anything he cannot, let's say, come up with a good idea for. And so that was basically, yeah, beginning of 2018, and we were not quite sure how to tackle the problem. So first, like as engineers, you tend to like be like, okay, let's just focus on the technology right away, and we did that for about a week or a week and a half, and then I was like, yeah, this does not make sense. Like we have to look at it more holistically, and so we got a bit of advice from the founding initiative at TUM. We talked to Unternehmer TUM and got some advice on how to yeah, let's say transform our idea into the possibility of a company, and actually join the boot camp there for 2 to 3 days. It's called Explore Boot Camp for Scientists. Was really eye-opening actually, because it was 3 days straight where you and other founders or potential founders talked about ideas you had and how you could build a company out of that. And there was this session where we had a fairly long brainstorm about different markets that could be tackled, and yeah, this sort of led us to see that okay, maybe to achieve the vision we do not have to start with it, but we can go for another market before that, and then really yeah, in a way start off with easier problems to solve to further go towards that direction, right? And yeah, right after that, I think we started all three our master thesis also at the chair of carbon composites, all with a topic in mind for, let's say, solving the first big problems for our to be found company. And yeah, that's I guess when we were all 100% committed, and it started.
So the three founders actually were tremendously involved in textile area, and you did your master's thesis, all of you in different areas involving fabrics. So one particular aspect that you could also consider was, going for a PhD in those particular areas, since you were primarily inspired by, let's say, the technical challenge of solving the technical problem and the challenge of it. So we'll talk about your why and personal motivations behind choosing to build a startup rather than going for a PhD in the last part of this conversation. But now let's talk about how have you evolved over the past 2.5 years or 3 years of working at Sewts, founding your own company, and doing the thing that you were planning to do for quite some time.
Mhm. Yeah, so I think uh, I couldn't even like when you asked me like this, I could not even say where I stood like 2 to 3 years ago exactly, personality wise. I just know that it's been like a huge like stream of evolution. So it's I'm pretty sure at that point I was in a place where I thought, okay, I know what I can do, and there's certain areas which I have not had any, say, contact points with, and I'm not so sure, like, can this be done or not, or can we reach that goal or whatever. And like certainly one of the biggest transformations that has happened over that period of time was that with every new problem you encounter, kind of, um, you are, yeah, you're sort of met with the, let's say, impossibility of, let's say, failing. You just like, yeah, I just have to solve it, like in one way or the other, and you do that with the first problem, and it somewhat works out, and then you do that with the second one, and then you're like, hey, like it seems like you can do almost anything after a while, and that's like really that's really motivating. Like when you see, okay, like all these things I thought I was not able to do previously, maybe you see yourself slowly working towards those, and getting better and better, and eventually you can just look at something and that you have no clue about, and make a good estimation of like, yeah, could I solve this, or how long would it take me to solve this. And yeah, that's I think one of the biggest developments right there.
I think since the problem that you're tackling at Suits is such a novel problem that you're targeting an unsolved problem essentially. So you have to be open-minded and creative, because generally what one would do is refer to the existing solutions, existing research papers and stuff. But with a problem like that, you have to kind of come up with new ways. So I think in that sense, you probably evolved that, yeah, if I can solve an unsolved problem and I can think of new solutions, then I can probably solve a lot of other different things as well.
Yeah, yeah. No, for sure. I think also that's like it took a long time to realize this, but I think this is what you learn in your bachelor's and many engineering studies is basically just to, let's say, get back up, because first few semesters of engineering you're usually hit with problems you do not understand, and once you have understood them, there's new set of problems that you got to work on. And so like this getting back up on your horse and continuing, that's I guess something that I realized, and that I have learned. And um, something else I have also learned, which was really valuable, is the importance of let's say talking with people and learning from other people compared to like research or whatever. Um, because like let's say initially looking at some of the problems, or let's say looking for solutions of some of my problems online, took quite a while, and yeah, you were not so sure, let's say, um, what you really got out of it, and if you had the right solution yet. And like going to fairs or talking to other founders, talking to experts in different areas for certain sensors, for certain, let's say, parts, that was uh, like so much denser knowledge, kind of, in a way. So one example is the Automatica fair here in Munich. So uh, I prepared for that sometime, I think 2019, looking for, or even 2018, looking for, let's say, answers to my questions regarding certain areas of computer vision and camera technology. And like what the 1 week of research I did before the fair was nothing compared to the one day I spent there, like talking to so many people, having in the end so many like phone numbers that I could call and, let's say, have a more detailed conversation about things. That really uh, got me motivated to say, hey, why should I always go the hard way and say, okay, I can figure this out by doing research online? No, I can, but it will take forever. Why not just ask for something? It's not a problem to not know. It's not a flaw. It's more like a skill to get help when you need it. So yeah.
You realize that rather than always trying to find the solution yourself, you could probably talk to other people and get to know different perspectives. And also, if it has been already, an aspect of the problem is already solved, you can probably just learn from another person and implement it directly, rather than going through the process of brainstorming or ideating or problem solving on your own.
Yeah, mo most definitely. So th I think that's actually the biggest difference between having like a startup and doing research. Like when you do research, you have to find something that no one other than you knows yet. And when you have a startup, you need to combine lots of, let's say, findings from different people and from research into a product or a service or something like that. And therefore it's not practical to try to solve everything yourself. That's in the end going to kill your company if you try that.
If you were to choose again, would you go for a PhD, or would you still be, doing a startup?
No, I definitely made the right choice here. So maybe sometime in the future, because a PhD has also like many really awesome, let's say, challenges and ways of learning. But I think founding a startup has been like the best choice ever, and I don't think I could have, let's say, um, learned in such a, let's say, wide variety of areas compared to a PhD. Yeah.
Yeah. And initially, probably you were doing everything, right? You were also involved in hiring, you were interviewing people. So, what are the areas that you were, involved in simultaneously, especially during the very early phases?
hmm hmm Yeah. So in the super early phases, you kind of like everyone is you're just the three of you, and you're kind of unsure what you're all doing. So it's like, as I said, you built this, let's say, kind of trust in yourself that you're going to go the right direction in a way. And so you do these many things all together, especially like, yeah, let's say registering for a company or things like that. They're very, very tedious if you have never done them before. So maybe to start off, like it took like more than half a year probably, so that we like until we would figure out which areas we would go to. So in the beginning, it basically was we all sit in the same room, something comes up, you just talk across the table. I say like, "Hey, I'll do that," or "Can you do that?" And therefore it was like all scrambled up. So there was like no order at all at who does what. And over time we got to be like a little bit more uh, in our areas. So I stayed true to the let's say mechanical part. So hardware development and testing and prototyping, with, let's say, a slight deviation in my master's thesis where I tried computer vision. Then yeah, obviously something that was really important to me especially was like doing the HR part, because I had no idea about HR actually, but I knew that was the closest thing involving people. So, and that's been like a very deep belief of mine since a long time, that people are one of the most important things of of a company. And so that's the part that I tackle. But I don't know, I like our brand. I registered that, and I went to fairs, and it's really anything, like really anything. And you gotta basically come up with the solution to any problem. And yeah, if you have no idea about something, you do a 5-minute crash course for yourself, Googling it, and then hope that you're doing best. So
I can imagine in the initial phases where like the three of you are probably sitting in one room and trying to just get the work done, whichever is urgent, and you kind of negotiate together and do it in that way. And comparing that with the status right now, like Suits has grown to, I think, more than 25 people, or how many are there right now, and it's way more ordered right now as well. Scrum is implemented, so I can see like there's a lot of systematic operation of the whole company. So how long did it take to actually realize that we really need to structure it and we can't go with this total spontaneous way of dealing with problems?
Yeah. So um, I think we're 19 people right now. And yeah, it was very, very important that we have some processes in place also now. Otherwise, we would be in total chaos, let's say. So I think the most important thing from the beginning on was that we were more clear on dividing up, let's say, areas, sort of. So for a very long time, we all still did investor relations in a sense. And then, let's say, when it all got too much, Alex took over that area, and I gave away the computer vision from my master thesis to Till. And so then we had this kind of neat separation, which was like, okay, Alex does investor relations and most of the business, Till does software, I do hardware, and Till and I also do some of the business part, whichever is, let's say, then applicable at that point. And yeah, like the I think the critical part for a startup is not where you need to be at a certain point, but how you get there. So it's constant transformation. So from 3 to 10 people, you need to make changes. Then from 10 to almost 20 people, you need to make more changes. And I'm certain this will go on until we have reached, I don't know, like a very, very big size. So you got to be prepared to basically, while your organization is running, you got to transform it all the time, in a way. And I think most critical is that you give people that start coming to Suits, that you give them, let's say, value, that you show them that they're important and that they can contribute to something, and that their work is valued and will be used in a way, and also um, to link that with responsibility, saying, hey, this is like, you kind of own this part now, or this part of the product or the company, and if you don't get it done, no one will get it done. So be sure to do your best. And I think uh, yeah, organizing this well is not trivial, but it's what people are looking for also. Like, people come to a startup because they're looking for purpose, they're looking for responsibility, for something to grow on, and for a challenge in a way. And like, being able to provide this while still having everything, let's say, fairly structured and non-chaotic, I think that's the true important thing. Yeah, the biggest challenge, let's say. Yeah. Not saying that we do this perfectly, but I think we've come a long way, and learned a ton.
Yeah, definitely. And I mean, that's definitely the reason why people come to startups, right? Because you would be able to have a greater impact, because your work would really reflect in the end product, right? And so you have a direct sense of responsibility. So
Mm,
you also
mm,
mentioned that you did your master's thesis for a change to try computer vision, and but you eventually then stuck with hardware and mechanical engineering. So what is it about mechanical engineering that you actually stuck with it? And your bachelor's was also in mechanical engineering, right? So you have been associated with that. So uh, going to the initial phase when you were probably making a decision of which area you want to do your bachelor's in, and coming back till now, like uh, what has made you stuck with mechanical engineering for so long, and why did you choose this particular field?
Yeah, yeah. Yeah, I will start with the thesis part because that's actually let's say quite a funny bit. So I thought, let's say back then when I started my thesis, that okay, I have a fairly good understanding of, let's say, the mechanics or the mechanisms behind easily deformable. So I have some experience in prototyping and testing, and so let's move more towards the software side of things. Let's go towards the computer vision part. So it was like truly novel to that, like no clue whatsoever about it. And then I picked a very ambitious thesis topic about extracting seams from yeah, towels in with a vision system. And so that was, yeah, in 2 and 3D, you have to say. So that was like a big step initially. And in the beginning, I scrambled a lot, and it was like a huge hassle to do that. And it kind of showed me that like I can get into that field and that I can understand it and work with it. But when I looked at like other people and how they did in similar problems was just frustrating. So I came from the mechanical engineering part, was like fairly easy for me to quickly solve problems and understand how things work and come up with really, really good solutions. And in that area, it took me like longer, 2 times, 3 times longer. And also comparing to others, it took forever. So that was the biggest learning for me, kind of that, okay, I I might be able to learn that, but like who do I really help with when I struggle so much and like someone else around me can do it like 3 times faster while they're not being able to solve mechanical problems that fast. So uh, it was kind of resorting back to like seeing my strengths and realizing that I wanna, let's say, keep the technical part in that area and leave the coding to someone who's quicker than that and give maybe creative input ideas. Um, and most funnily, actually, so after I have solved the problem of finding seams in terry cloth in towels in my thesis, I think 4 to 8 weeks later, our machine learning system that Till had written was like good enough to get better results than what I have gotten with classical computer vision. So yeah, that also kind of shows, okay, maybe go back to the initials. Um, and now to, let's say, resort back to the second part of your question. Why have I started with mechanical engineering initially? So to me, it was always, I've always been a tinkerer. Like I always had to have something in my hand. Like my mom would even like when I was younger, like clear the whole table of things like far away from me, so I could not just fiddle with something in my hand. And like the sense of touch and like yeah, being able to hold something and interact with it, that's been always there for me. And I never really knew what to do about it. So I was building small things, experimenting, like blowing stuff up in our backyard when I was younger. So and then um, when I was 16, I had an exchange year in the US. Went to a really really awesome family in Utah, and they were both engineers. One was like my host father was electrical engineer, and my host mom was a aerospace engineer, and they kind of like pointed me towards that direction of mechanical engineering when they saw like me taking apart stuff and so on. And that was, I think, the initial, let's say, knock I got. Yeah, it was kind of a spark that I felt that this is the right thing for me to pursue and go for and study for, and gave me kind of a direction to to apply. And that's why I started the degree, and I think I have never regretted it. I know many people who have, let's say, started with a degree and then pivoted either a little bit or a lot, but for me, like, it was the very right thing to do, and it took until my master thesis pivot to see, it's still the right thing for me to work on.
Yeah.
So yeah.
I think like you say it very easily now, but I think it must have been a bit difficult to take the decision after you did your master's thesis, let's say in computer vision as well, because generally like it's machine learning and stuff is also kind of the popular thing to do, right? Because it's everywhere, it's in demand as well. But you still had like the faith that you are really good with mechanical engineering and you want to stick with that. So focusing on your strengths, and eventually also like the computer vision experience did help you with the understanding the whole Sewts pipeline and getting involved in it as well. So win-win, I would say.
Most definitely, yeah. No, I must actually say I think it makes a lot of sense to know, like, to figure out what you're good at, and then try to pursue that, rather than, let's say, only looking at trends in a way, and also thinking about, okay, let's say other areas of engineering, they will not die out because of machine learning, but they will need, like, to become a lot better at, let's say, pursuing problems. That's like, when you look at startups nowadays who pursue machine learning, especially in the area of vision, then usually there's a detection that you can do, but then, like, eventually you have to get into contact with some material, right? You have to pick something, grasp something. But if this is a very complex task, and not really, yeah, not really only possible with software, you eventually have the problem that you have to touch something. And if there's no expertise in your company about that, then either you stay solving, let's say, uh, only certain problems that you can solve with current actuation and sensing methods, um, or you, I don't know, you kind of lose contact to newer areas.
And actually, this kind of expertise would also like understanding the dynamics of how, let's say, cloth is moving, or when you're trying to grasp how the cloth is changing its state, so to say, is also essential if you're trying to build a simulation. So this expertise is, I mean, inevitable for a company that's dealing with fabric manipulation in essence. So I think, yeah, that's a very important part which cannot be ignored, right? Grasping, without grasping, I mean, no amount of computer vision you do would be enough. So now let's move to the second part where we'll talk about Sewts vision, and more technical stuff that is going on at Sewts. So to begin with, let's can you elaborate briefly of what Sewts does, what its maybe customers are, and in which area, which market it's focused on currently? Hey guys, I really hope that you enjoyed this particular conversation and it helped you in some way, shape, or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook, and Instagram. So make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms including Spotify and Google Podcasts.